In this video, we are going to talk about solving systems of equations using elimination. As always, you are going to watch, you are going to listen, and you are going to take notes, this time on your guided notes half sheet. So we have talked about solving our linear systems of equations by adding or subtracting the equations together. However, in some linear systems, you cannot eliminate either variable by doing this. So when this happens, you need to multiply one or both of the equations by a constant so that adding or subtracting the equations will eliminate one or more of the variables. Now, as we talked about with our adding and subtracting, typically I won't subtract, I will add, and if I need to subtract, I will just multiply through by a negative in order to get those opposite coefficients. Let's take a look at our steps for using elimination. Our first step is to decide which variable to eliminate, and then multiply one or both of the equations by a constant so that the coefficients of one variable are exact opposites. Now we've practiced doing this. Remember, we want something like a 2x and a negative 2x, or a negative 6y and a positive 6y. What this allows us to do is to add or subtract the equations, and again, if they're exact opposites, we will not add or subtract, we will simply add the equations to eliminate one variable, and then that's going to give us an equation where we can solve for the other variable. Once we have done that, we are going to substitute the value into either original equation and find the value of the eliminated variable. And as always, we're going to plug in to check our answer. Pause here if you need to in order to continue writing down our steps. I am going to move forward and take a look at our two examples. Okay, starting with our example 1. We want to solve the system of equations 3x plus 8y equals 7 and x minus y equals negative 5. To start, we will use the elimination method here because they are both in standard form. However, I don't have exact opposite coefficients. So I don't have, for example, a 3x and a negative 3x, or an 8y and a negative 8y. So I need to multiply one or both of my equations. Now when you're deciding what to multiply by, take a look at your coefficients. Here, that's a 3 and a 1. Remember, you are looking for the least common multiple, the smallest number that they both go into. You could also just simply multiply them. 3 times 1 is 3. In this case, that's our least common multiple. If you look at your y's, an 8 and a negative 1. 8 and negative 1 would be 8 would be our least common multiple there. Don't worry about the signs just yet. So I can either eliminate the x by getting them to 3x and negative 3x, or I can eliminate the y by getting them to 8y and negative 8y. Since the y's already have a positive and negative, I'm going to choose to eliminate the y. In order to do that, I'm going to multiply the second equation by 8. So my first equation will stay the same. My second equation, I'm going to multiply everything by 8. So 8x minus 8y equals negative 40. Then I'm going to add my equations together. Now notice immediately right there, I eliminated the y. If that doesn't happen, then you've done something wrong. You got to figure out what it was. Combining my like terms, 3x plus 8x is 11x equals 70 plus negative 40 is a negative 33. Signs are different, so I subtract and keep the sign of the larger. Now that gives me a nice, easy equation to solve. Dividing both sides by 11, I get x equals negative 3. Now remember, what I'm looking for here is the point that makes both equations true. So I need an x and a y. I can go into either equation. I'm going to choose the second one because the numbers are smaller. Plug in the x, so plug in -3 for x, and solve for y. Adding 3 to both sides, I get -y equals -2. And then don't forget to divide by -1. So y equals 2. My answer here is the point -3, comma 2. X is -3, y is 2. I can do a quick check. So my two equations, 3x plus 8y equals 7. And x minus y equals -5. And I'm going to plug these two things in. So plugging -3 in for x, I get -9 plus 16 equals 7, which is true. And again, plugging -3 in for x and 2 in for y, I get -3 minus 2 is -5, also true. So you can always check your answer on these. Let's move on to example 2. I am solving the system of equations -3x plus 9y equals -3 and 4x minus 13y equals 5. Again, remember what we are looking for here is the value of x and y that makes both equations true. First, I need to decide which variable to eliminate. If I look at my x's, my least common multiple between 4 and 3 is 12. My least common multiple between 9 and 13, they have no common factors, so I just need to multiply them. 117. And obviously the 12 is smaller, so I'm going to choose to eliminate my x. Okay, so to eliminate my x, I want to get a 12x and a -12x. Notice this time I'm going to have to multiply both of my equations because neither one of them are already at the 12. So I'm going to multiply the first equation by 4 and the second equation by 3. So that'll give me a -12x in the first equation and a positive 12x in the second equation. So multiplying by 4, remember to multiply everything. -12x plus 36y equals -12. And the second equation, multiplying everything by 3. 12x minus 39y equals 15. Now when I add my two equations together, -12x plus 12x is 0, so it's gone. 36y minus 39y, signs are different, so I subtract and keep the sign of the larger. -12 plus 15, signs are different, so I subtract and keep the sign of the larger. Again, it gives me a nice, easy equation to solve, so I just need to divide both sides by -3. Now that's my y value. I need my x value. Again, I can go into either equation. This time I'm going to use the first equation. Numbers are a little bit smaller. I'm going to plug in the y value. And I'm going to solve for x. So I get -3x minus 9 equals -3. Adding 9 to both sides. And dividing by -3. giving me x equals -2. Now remember, when you write your answer, it's a point x comma y, so it's -2 comma -1. Make sure to put it in the right order. And again, we can do a check. So my two equations, -3x plus 9y equals -3, and 4x minus 13y equals 5. This is me just checking. Once I get to here, I've got my answer. Now I'm just checking to make sure I did it right. So plugging -2 in for x and -1 in for y. I'm going to get 6 plus a -9, or just -9, equals -3. That's true. And again here, I've got to make both of them true. Plugging -2 in for x, plugging -1 in for y. I get -8 plus 13 equals 5, which is also true. So again, to use our elimination method, we want to decide which variable to eliminate and multiply so that we can get exact opposite coefficients. We say add or subtract, but really we want to add because we're making them opposites. To eliminate one variable, and then solve for the other variable. Substitute that back into one of the equations to find the value of the eliminated variable, and then plug in to check your answer.